तीसरा घर छोड़ो, चौथा घर होगा ना।
उधर में जाता है।
कोई नहीं पता मेरे को।
फ्रेश जीजू जी आपका घर फ्रेश के सामने।
आप ऐसे ही इधर
पहला भी तो नहीं है वो।
इधर का मतलब वो दिन याद है इसको मुझे नहीं पता था कैश बेटा को ऑटो को लेके ये मतलब हम लोग मारपीट
टची नानी
चलिए आगे।
Yes, ma'am.
हाँ तो एवरीवन इज लाइक
No, ma'am.
आगे। Okay, boys. Yeah, do you need? If you want to use it outside, come then. No problem. Yeah, many.
सब कुछ हो नहीं है बताए कि बात ये हमारा पीछे रहेगा सब बात बहुत बड़ा
very much treated.
यहाँ पे टेक्स्ट one part of this lesson was we are actually seeing regarding the flow of current. Okay, there are different types of formulas, different type of laws. Most important, of course, we have seen Ohm's law, and we have seen also what happens if you are connecting pulse, pay attention. If you are connecting it in series and parallel. Now, the second part of the lesson is what we are going to be talking about is the heating effect. Okay. Now, this is something that's quite obvious because when you pass current, and if at all, there are three different types of substances. One is if it is a good conductor, the current passes through without heating much. Second thing is if you are using an alloy like a nichrome copper, okay, not copper, nichrome, alloy, then it causes a little bit of heating effect. Steel is an alloy, but basically we don't use it for such type of purposes. Now we are talking about what happens here. Why should it actually cause a heating effect? We require it for various type of gadgets, like for example heating water, heating food. Okay, cooker and other electric cooker has got a coil. Bread toaster has got a coil. Okay, have you noticed what happens when it is heated? When we switch it on, the element inside, okay, it becomes red hot. So that is when we are making use of current in order to produce heat. So that is the heating effect of electric current. Now let's try to understand why should it actually heat up. When you are talking about a conducting wire, a good conductor, we said that the electricity flows through the current, the movement of the electrons is absolutely fine. But if the little bit of resistance is there, then basically what happens is these electrons are colliding not only with the atoms which are present here, but it is also colliding with the other electrons which are moving, and therefore there is going to be an increase in the kinetic energy. The greater the kinetic energy, obviously it is getting converted into heat energy. Okay? So this gets effectively converted into heat energy. Is that okay? Have you followed? So that is one thing that I want to stress on, is for the heating effect, we don't use a good conductor. If it's a good conductor, then obviously it does not. Okay, there's not much of heating. Okay, for example, these wires, are they getting heated up? No, we don't want them to get heated up. Correct? But there are certain gadgets where we want heat to be supplied, like for example, boiling milk or boiling or probably in an oven where we actually want some kind of a heating effect. So that's when we are going to be bread toaster. So that's where we are using such type of wires. Another thing that
So
you will notice,
micron wires are the
mostly used because those are the alloys. Okay. Another formula that we have already learned is R is equal to rho L upon A. You remember this formula? We want a resistance to be more. So what does it tell us? What happens to the length? Should the length be small or the length should be long?
long.
Directly proportional, inversely proportional? Directly proportional. R is directly proportional to L, isn't it? So if you want more resistance, therefore, you have to take a longer length. Is that okay? Did you understand? Now, if you look at those traditional bulbs that we have, nowadays, of course, they're all CFCs, okay, fluorescent. But you find that this coil inside is all twisted like that. Have you noticed?
Yes.
Okay, it's all coiled up. So by coiling up, what are we doing? We are increasing the length. Greater the length, greater is the resistance. Have you all followed? Next, what do we find? R is also inversely proportional to cross-sectional area. What does it tell us? If I want more of R, that means it has to be a thin wire. Will you notice how thin this wire is? Will you notice? Okay, it's a very thin, fine wire. So the cross-sectional area is very thin and therefore the resistance is very high. Is that okay? Did you all understand? So the choice of our material depends upon what gadget we want it for. If we want it for a good conductor, then obviously we use copper, aluminum. Okay. Suppose we want a wire for heating effects, then we are going to use an alloy like chrome, which has got a longer length and the cross-sectional area is also going to be very fine. Have you seen the toaster if it is switched on? Okay, those coils are getting heated up, right? And why have they mounted so many times? Because you are increasing the length. Correct? So the length is more, cross-sectional area. It's a very fine thing. So obviously we are creating resistance so that more heat is being produced. And what type of material can this be? One, of course, we have said that it could be an alloy. Another very element that one of the elements that is being used is tungsten. Okay, that's because tungsten has got a very high melting point, very very high melting point. So even though it is getting heated up and it is going to emit light, it is a luminescent bulb. What does it mean? That heat is being provided. This heat is also getting converted into light energy. Is that okay? That is why it is emitting light. It is a bulb which is going to emit light by the heating of this particular element. So once again, we are using a choice of element will be, here it is going to be tungsten, so that the melting point is very high and this coil should not melt down. Okay. Another thing you will notice is that this is sealed here. It's not an empty wire which is coming here. Okay. What should be filled up inside? Is it going to be air?
Yes.
Inert gases? Why inert gases? We have started reading about types of chemical reactions.
Then a chemical reaction will occur and
With what? Chemical
With
reaction.
acidity.
With? What is there in air?
electrons.
Oxygen and
Carbon.
yeah.
Nitrogen.
Okay, nitrogen, oxygen, fine. Almost 21% of our air is oxygen. So if you are using any other element, it could be at such high temperatures, there can be a process of oxidation. What is oxidation? It's a combustion reaction with oxygen. So we want to prevent this. So basically what is happening? Air is being taken out and we are putting an inert gas. It's not necessarily an inert gas like argon or neon or whatever it is, but nitrogen is one of the gases that can be filled up. Okay, because nitrogen there's no oxidation process. So what are the various things that you can talk about this tungsten bulb or basically the incandescent bulb? Long wire, thin cross-sectional area. The choice of material is going to be tungsten. Okay, and the way it has been sealed, where air has been taken out a minimal quantity of oxygen in order to fill induced oxidation process. Is that okay? Have you all followed? Why I'm stressing on these points is this could be one of the questions which is going to be asked. Okay? Come to page number 188. Are you with me? Is it page 188?
Yes.
Yes. You have your textbook with you? Heating effect. Yeah, we know that.
We know that a battery or a cell is a source of electric energy. The
And then
chemical
it's a
reaction
battery
with the
or a
cell
cell. What is the difference between a battery and a cell? Many cells. Many cells together form a battery. Okay.
The chemical reaction within the cell generates the potential difference between its two terminals that sets the electrons in motion to flow the current through a resistor or a system of resistors connected to the battery.
Stop. After each sentence, I'm going to ask you a question. Okay. Now my question is, what sets the electrons flowing through the wire? What sets it? Electrons are flowing. Okay. What actually sets it? Read that sentence.
Potential.
Read that sentence again. When you read it, pay attention. Resistor will allow the two terminals. How should the two terminals be?
Potential difference.
There should be potential.
There should be a potential difference. So what is important for us to have this potential difference? Two terminals of what?
Conductor.
Two terminals of what?
Battery.
Of a cell or a battery. So what does a cell or a battery do? It helps to provide a potential difference. Do you understand? What is the function of the cell? A cell is providing a potential difference. So that's why the flow of electricity is from the positive to the negative terminal. Do you understand? So when you read the textbook, pay attention and read. You are not reading it just for the sake of reading. Any of these things can come for your MCQ. Read.
We've also seen in section 11.2 that to maintain the current, the source has to keep expanding its energy. Where does this energy go? A part of the source of energy in maintaining the current may be consumed into useful work, like in rotating the blades of an electric fan. The rest of the source energy may be expended in heat to raise the temperature of the engine. We often observe this in our everyday life. For example, an electric fan becomes warm if used continuously for longer time, etc.
Okay, 1 minute. Has anybody tried to stop a fan after some
Yes,
time?
ma'am.
Is it warm? It's very hot.
Yes.
Yeah. Similarly, that type of a bulb, of course, that type of a bulb is no longer, we don't use it any longer. But please do not do that. Switch it off and then maybe you can try to do that. That's okay. But when the switch is on, don't like
Most of the
that.
time I use a marker. Put it on the center.
And you can do concentric circuits. Okay. Did you try touching a bulb
Yes.
after it has been switched off? It's very warm. Okay, so we are talking about how electric current is getting converted into heat energy. Okay, electrical energy getting converted into heat energy. Sometimes heat energy can also provide light energy, as in the case of a bulb. And
On the other hand, if the electric circuit is purely resistive, that is a configuration of resistors only connected to a battery. The source energy continuously gets dissipated entirely in the form of heat.
okay, stop. What does it mean by if the electric circuit is purely resistive? What does it mean?
Let the electricity pass.
Think about it. Think. You're coming very close to that. What happens if it is purely resistive? What is the meaning of that? Resistive means what? Resistance.
No electricity pass.
That means that because it offers a very high resistance. Okay, did you understand? So if higher resistance is there, it is getting converted into heat energy, more of heat energy. Come, continue.
This is known as the heating effect of electric current. This effect is utilized in devices such as electric heater, electric iron, etc.
Okay, underline those two gadgets. Iron heater, okay, water heater is there, toaster is there, yeah.
Consider the current I flowing through a resistor of resistance R. Let the potential difference across it be V. Let T be the time during which a charge Q flows across. The work done in moving the charge Q through a potential difference V is Vq. Therefore, the source must supply energy equal to VQ in time t. Hence, the power input to the circuit by the source is P is equal to VQ upon T is equal to VR. Or the energy
So we
supplied.
understand how P is equal to P into I. What is P? It is the power. Okay.
Or the energy
V,
supplied.
wait. V is what? Potential difference. What is Q? Charge. What is the unit of Q? Coulomb. Current is Coulomb. Yes. Okay. And T of course is time. You remember that formula Q is equal to I T. Okay. If they have given us Q divided by T, what does it give us? It gives you I. Therefore, P is equal to G into I. You understand that part? Yeah, put it up. Please.
Or the energy supplied to the circuit by the source in time t is P into T, that is VIT. What happens to this energy expended by the source? This energy gets dissipated in the resistor as heat. Thus, for a steady current I, the amount of heat H produced in time T is H is equal to VIT. Applying Ohm's law, we get the H is equal to I square into R into T. This is known as Joule's law of heat. The law implies that heat produced in a resistor is directly proportional to the square of current for a given resistance and directly proportional to resistance for a given current. And directly proportional to the time for which the current flows through the resistor in practical situations when an electric appliance is connected to a known voltage source. Example 11
Yeah, this is equation 11.21 is used.
is used after calculating the current through it using the relation I is equal to V upon R.
Ah. Okay, did we understand this part of it? Okay. Before we start writing down the formulas and all that, 1 or 2 points please take down. Heating effect of electric current, that's your next section. First point, I'll just give you in bullet points. You can use these bullet points for any of the answers that you might require. First one, a battery or a cell is a source of electric energy. A battery or a cell is a source of electrical energy. Second point, the chemical reaction in the cell, the chemical reaction in the cell generates the potential difference between the two terminals. Between the two terminals, and this sets the current to flow through the resistor. Next point I want you to remember. If the electric circuit is purely resistive, if the electric circuit is purely resistive, then the source energy gets dissipated, D-I-S-S-I-P-A-T-E-D, dissipated in the form of D-I-S-S-I-P-A-T-E-D, in the form of heat energy. Next point. This is called as the heating effect of electric current. Okay, ninth standard we have also done a part of our physics lesson, something about work, energy. Do you remember? Power. You understand that? You remember how do we relate power and work upon time? Do you remember this formula? Yes or no?
Yes.
Yes. Okay. So here, how do we define power? Power is nothing but the rate at which the work is being done. Okay, that is basically we are talking about mechanical work and mechanical power. Now the same concept can be expanded or extended to electrical circuits also. Now here what is work? Work is nothing but the energy. Remember that work and energy, they are all interrelated. Both of them are measurement in joule. Okay. If a person has energy, then he is able to do work. Do you understand? To do work, you need to expend energy. So that is how work and energy, both of them are related to each other. But when we are talking about power, this is nothing but the rate of work being done. Okay. Now we have extended the same thing here, power if you want to calculate. But we also know something about W. What is the formula that we have learned in the chapter on electricity? W is equal to
V by
V.
upon
No, see, W is equal to V.
Q
Look at your table, look at the first few pages that we have done. The first thing about potential difference we have done. How do we define potential difference? W is equal to
both that one and
VQ. W is equal to V into Q. Remember this? Yes or no? So now we are going to substitute it here. So W, instead of that I'm going to write it as V and Q. And there's a T there. Okay? But Q is equal to I into T. Correct? So I is equal to how much? It is Q upon T. Is that okay? Now I have a Q by T here, Q by T here. So now I can substitute it and write it as V is equal to V into I. If you understand this. Okay? Power is equal to V into I. If I know the potential difference of the supply, and if I know the gadget, how much of current it needs, then I can easily calculate the power. Okay? And power, what is the SI unit?
What?
You understand? Okay, come on, take it down first. Take down this. Power is equal to the rate of work done. Okay. Now, what type of work? It is the electric work. Remember, we are not talking about the mechanical work, but you can still have the same formula. But P is equal to W upon T. What is W? W is nothing but the work done. Right? And we know that W is equal to V into Q. What is Q?
Charge.
Okay. And in SI unit?
Cool.
Coulomb. Right? You remember? So substitute instead of Q, I'm going to write Q is equal to IT. Okay. And but Q I divided by I is equal to Q upon T. Okay. So therefore we have got T is equal to V into I. Next, one or two lines, just write it down. So we have a formula, P is equal to V into I. Next you write down the energy supplied to the circuit
energy
supplied to the circuit by the source in time t. Time t. Okay, is P times T. Is that okay? Right? So instead of P, what can we use? We can use P is equal to V into I. Correct? So therefore, your work done is equal to V, I, and T. Substitute. P is equal to V into I, and substituting it, you're getting the energy spent is nothing but VIT. Now what is this energy? This is nothing but heat energy. So heat energy, H is equal to VIT. Okay. So it was the scientist. Once again, we are talking about a numerous scientists who have done a lot of work. Joule's law, where we have got H is equal to I square R and T. Let's see what it means. Harush, H is equal to I square R T. What does I stand for? Current. R, T. Now I want everybody to think calmly. Is it directly proportional or inversely proportional? If I want more heat, I have to supply more current. Okay, if I have 5 seconds or 5 minutes, how much heat is produced? Obviously, time should be more. Okay, current should be more. It is the square of the current. Resistance should be more or less? More. Greater the resistance, the greater is the heat. Don't you see it is a directly proportional to H is more, therefore R definitely is more. What about time? More time of the supply. So what does Joule's law tell us? H, that is the heat energy produced, is directly proportional to the square of the current and the resistance as well as the time for which the current is being supplied. Is that okay? Many children forget to use this word square. They just write it as current. Remember, it is the square of the current that is going to be supplied. Is that okay? Come on, please write down. Statement of Joule's law. It is given in the next page, you see. You want to read that? Applying Ohm's law, we get H is equal to I square R T. Next page. This is known as Joule's law.
Applying Ohm's law, we get H is equal to I square RT. This is known as Joule's law of heating. The law implies that heat produced in a resistor is directly proportional to the square of current.
Underline the word square of. Remember to learn it as square of.
Square of current for a given resistance. Directly proportional to resistance for a given current. And directly proportional to the time for which the current flows through the resistor. In practical situations, when an electrical appliance is connected to a known voltage source, equation 11.21 is used after calculating the current through it, using the relation I equal to V upon R.
All of you please write down Joule's law statement. Write down. Joule's law states that the heat produced in a resistor, the heat produced in a resistor depends on, or it is directly proportional to. What are the 3 things here? I, R, and T. So for all those 3 things, write it as a subpoint. Now we read, no? What is it?
Square of current.
There are 3 points in it, right? Square of the current flowing through the circuit. Second point, write it in point, one below the other. Wrote all the 3 points. Okay, now we have Joule's law. Okay? Okay, right there. Finish writing, completed. Finish? Done up all the 3 formulas. I'm going to put up the third formula now. What is first formula? What did we write? H is equal to? Look here. H is equal to? Second formula?
I square
I square R. Now I'm circling I square. Why? Because we are going to once again use Ohm's law. What is V? Correct? I want to find out I. Now, what is I? V upon R. Substitute here. So H is equal to what? I square. So V square divided by R square times R times T. So what will you get? H is equal to V square T upon R. Take it out. That's the third formula. The first one, this is the second one. Why we have written all the 3 of them is it's sometimes in the word problems, we may have to use any one of these formulas. Right on the third one, I've given you the derivation.
Three formulas of H are there.
Yes, for
VIT, IR square, I square dot R dot T.
Yeah.
And V square dot T.
dot is nothing but multiply. Okay, all of you pay attention here. See now here. If V, I and T is given, twice, then you can use this. But there is, remember, there is no R. If you see this formula, there is no R. So if R is given, you cannot use this. So then you will have to use either this or this. What happens in this formula? Garan? What's happening here? What are the 3 variables that we have given? I, R and T. What is not there?
P.
Very good. V is not there. Did you notice? If V is given, we cannot use this formula at all. Go to the third one. Out of the four variables, what is not there? I is not there. Very good. Did you see that? So what are the variables now? V, I, R and T. Okay. So depending upon what is available, that is when you have to use any of these. Is that okay? Yeah. Go to the table category. I'll give you a chart there. Go there. Go back again. In your notebook. Or traditional. Anyway, I want you to write down all the three of them
Just
together.
one,
What was the last name?
row resistivity.
I told you to leave a whole page there. One full page, that's why, yes. Next you write down about P. All of you please write down P is equal to VI. Write down at the top, below somewhere you write it on the same page. P is equal to VI, where P is of course power. I'm writing about the formulas now. Okay? P is equal to V into I, you can write down this. P. Power is in what? Now I'm asking you to put all the three formulas together for you to remember. Okay, not in the table form, but you put down all these three formulas together. Did you write down all the three formulas together?
Yes,
Then it's done. Okay. Come to example 11.10.
What is the symbol for V? Symbol for V? Like, of the value, like something.
H will write, then the thing SI unit will be in joule. It is expressed in terms of joule. Just below this. Just below joules. Okay. You see this example? Okay. Cover the book. Try to take down only the numbers that are given. Okay, and let's see which formula we are going to use. Electric iron consumes energy at the rate of 840. They have given the capital W. What does it tell us? What does it tell us? First of all, try to understand what we are talking about. All of you have used an electric iron for ironing your clothes. Okay, so there are settings there. There are settings.
Cotton says
Correct, correct. Can we use the high this thing? Can we use a high current for silks and nylon? Definitely not. So we require very less amount of heat. When do we require maximum heat? For cotton, denim's or cottons, definitely you require more amount of heat. So the information which is given to us is, boys, if you want to talk, the door is open, walk out. Just walk out, that's all. So this is what is the information which is given. 840 watt when it is set at maximum and 360 watt when it is set at minimum. Now the moment we talk about W, what does it tell us? It is power. Okay. And then we have got V, I, R we have to find out. What is the formula that we can use? Ayush?
V upon V is equal to
Which formula shall we use here?
P equals to P upon R.
E is equal
I
to?
equals to P upon.
Yes, very good. So this formula, VI, V is equal to V into I, therefore I you can find out here. What are we talking about? Let me ask you.
It's 42 upon 11.
As you do the calculation, you have to do many times. Because when you're coming to the board examination, your presentation is probably you're writing your papers and also you provide 3.8. How much do you get?
3.8.
40 upon 11. 3.8.
Ah, 42.
840 divided by 220.
220.
Correct. So that is what 42 divided by 100.
3
3.82.
2 कैसे आया? 2 कैसे आया? 1 आएगा ना?
You see the third decimal, no?
2 1 होगा. हम it's 3.81 गलत है. देखिए. करके देख. तू क्या है? 3.8.
Do the next. Or if it is more than 5, then obviously it becomes 2. When you put it 818 आएगा ना, 818 is equal to 82. Is it? More than 5. Okay, do the next one. How much you get? So 3.8. Cut this out and make this as 2. If it is 5 or more than 5, you put 1 on the other decimal. That's why it is 8. Correct. That is right. 1 8 correct. So it is 82. That's perfectly alright.
क्या सही बोला नहीं चलना ये अभी नहीं
Okay, what about the next one? Do the next one. Guys, come on. Next one. Do the next calculation. Why are you talking? Do it on your own. You want to do it. Here, I put up everything here. That is over. Next one.
3.82.
कैलकुलेटर से ज्यादा पता है सबका दिमाग में चल रहा है.
Come on, come on. There's one for maximum, there's one for minimum. I want you to do for both. I want to see your calculation. Come on, hurry. Then you come here. I want to see it. Raj, yours also. Fast, come on. P is the same thing, right? Power here is 360.
As per the V1 V, same that's all.
But B will be different here. Value of P is 360.
1.63. I'm 18
1.63. Do the next digit and tell me. 1.63 bar. Okay, bar. Okay, fine. So suppose I say I want you to.
Approx 1.5.
So if it is 6, if it is 5 or more than 5, you correct it to the second decimal. So you will get it as 1.64.
Approximately take 1.75. Approx 1.5.
Why 7.5?
70.
Why 70? 70 is so different from 63. Second decimal place I want you to do it. That's more than sufficient. Okay. Now in both the cases, now I want everybody to pay attention. Okay, now you have calculated current in one case. If it is maximum at 840 watt, pay attention 1 minute. You are using current of 3.18 amps. When you require less amount of power, then obviously here it is 1.64. Did you see that? Did you see? Compare the power and the current. Compare the power and the current. Did you see that? Now, there's another part. What is the current and the resistance? Now calculate the resistance. Ohm's law. Once again, V is equal to I into R. Now I have to calculate R, which is equal to V upon I. So R is equal to V upon I. Do this for both the cases. I want to see your document. Correct. So current, first, second, 60. Yeah, put this. Completed, I want to see the working.
No, second one is 360 upon 220.
Yes. That is for finding out I. Now you have finished I, no? Have you done it or no? How much did I get? 57.6.
And second one is 134.1.
So R is equal to 50. How much did you say? 50?
134.15.
No, first one. 57.6.
57.6.
How much is that? 124.1.
Now is it necessary to rounded off.
I finished my discussion now. I'm not going back. I'll let him do it on his own. No, don't. Because I have finished my discussion, he has to understand. Because I'm coming around to see your calculations. Girls, I want to see the calculations. That's why I said you keep it. I want all calculations on the same page. How do I know what you've done? Yeah, you draw a problem like that for rough work. That is correct. Show all your rough work there. Yes.
I'm 1.6.
What did you say with 1.64? Got it. Okay, next one. Next one. Okay, now next one. What is V there? For the second one, what is V? Yes, 220. And I, you have whatever you have, 1.64, correct. So shift the decimal. So it is 22000 divided by 1.64. Take out the decimal. Okay. You will go out of the class only if I check your calculations, not otherwise. Fine, come and see. Okay. Now, there's another thing that I want you to pay attention to. Pay attention, pay attention. Okay. What did we see here? Current is 3.18. Okay. Resistance is 57.
7.6.
Pay attention. What happens if the resistance is increased? What happens to the current? If resistance is increased, what happens to the current? The current is decreased. Did you see that? If resistance is less, then the current is low. So this is a classic example of actually backworking and understanding what is, how can the current be monitored by using that resistor. Okay, variable resistance is what we are calling. Similarly, this
Regulator.
it's a regulator. What is present here? We have got a resistor, variable resistance. Okay, if we want slow speed, that means we are increasing the resistance so that the current is low. But if we want high speed, more current has to be supplied. That means the resistance has to be. Did you understand this concept? This example is very good because it helps you to understand the relationship between power, okay, and current and resistance. Is that okay? Can we go on to the next one? Now, those of you who have not done this sum, stop, pay attention, let's start doing the second one. Ready? Look at example 11.11. Try to cover your book, don't look at the solution, do it on your own. 100 J, what is the J? Joules, very good. So that is the unit of work. Is produced each second. Time is how much? Each second. In
So I'm telling you once.
months. Okay. Resistance 4 ohm, R. R is equal to 4. Find the potential difference across the resistors. So what all is given? H is given, R is there, V is there, P is there.
Third one.
Which one?
Third one.
I square R upon T.
No.
First one,
First.
VIT.
V I T. V is
Say,
equal
B is not get.
Second wala.
Second.
I square R T.
I square.
There are two steps. There are two things that you have to do. First, find out I. H is equal to I square. I find out I. Then, using that I, you can find out whatever they're asking potential difference. Okay, now let's. I'm putting it up here.
One second.
I square R T. First, find out I.
Phi is equal to I. Phi.
So, H is
A.
equal
Phi ampere is equal to I.
Yes, ma'am.
See? Keep T and R. So,
Divided
find
4
out.
किया I square I 25 I square किया तो I तो I
No. Do here, see here. H is how much? 100. Arush. See here, Arush. You can put it as 100. Correct?
I transferred the square.
R.
I is fine.
Wait. R is how much? 4. Okay, this is 1. So 100 divided by 4, that makes it 25. Okay. I square you will get it as 25. Therefore, I is equal to root of 25. That's
That is this.
What will be the unit?
I current. A. Go to this right.
Let's move.
That's right. Very good. You have found out
I
I.
is equal to I.
I.
Is equal to
Next you have to find out what is the potential.
4 is equal to 20 O. 20 O.
Do the next one.
What is B?
See the sum.
Oh,
B,
B. Sorry.
So I you have got it as 5 amp. Varna finished?
This one.
Kitna hai?
5.
Okay, next part. What should you actually find out? Find the potential difference. Did we find out potential difference? Use this formula. V is equal to I into R. Easy now. Okay. Okay, go on to the next one. Go to the next page. How many of you have finished this chapter in school?
We just
finished.
Basic school somewhere.
Oh, okay.
Light chapter just finished.
Light is finished. Okay. What about your school?
This chapter 6 March.
But it's not yet complete. It's not yet
The
complete.
teacher was changed, then she went for board correction and
Oh, okay.
then she again went for.
Now you're getting confidence about how we have to go about it. Let's look at these set of questions there. Look at the third one, that is also, do the third one first. Third, here.
Is a heat equal to
20 ohm, what is given? 20 ohm, current is 5 amp, heat developed 30 seconds. Write down the formula first.
So, first, so heat is
First sum.
electric
3,000 joules. 1,550.
Not there, that book. Right? You take it. Stay, come, give it.
Yes, ma'am. No.
Suppose you put it as 1.5. 10 raised to power of 9.
Next questions are not in.
You have said 15,000, right? Shift the zeros. So if it is 15,000, suppose about 5, split to 10 raised to power of 4. That's your answer. Answer.
3,000 joules.
Very good. Okay? So what I was telling them is, suppose you want to write it as 1.5 times 10 raised to power of 4.
Kilojoules also can be, right? Kilojoules.
You can also write it as a yes. 15 kilojoule also is the right perfect. Understood?
Second.
Divided by 1,000 if you do, then you can convert it into kilo. Anish, finish.
Yes,
Karma, doing. Can we do the second one?
okay.
Second.
Got it.
1 hour approximately takes 60 minutes.
Yeah. 1 hour, yeah. It has to be in seconds. 1 hour,
360.
60 times 60.
3,600. It's been 96,000 coulomb of charge, so there's nothing like charge.
So,
Correct?
charge is what it
Q.
is. Q. Very good. Think of a formula which has Q.
P equals to Q upon
Q.
by T. Q is equal to I is equal to Q by T.
Again, Q is equal to IT. Therefore, I is equal to Q by T. Use that. Use that formula to find out I.
It is voltage.
Answer.
Second.
Voltage. P voltage.
For me, I is equal to Q upon T.
Okay, let's put up the second one here. Now I that you get, V upon T, just keep it as such, don't find out the decimal and all. Once you substitute it in the next formula, then it of course gets cancelled out. Is that okay? So first step, for us to write down the first step, okay, Q is equal to I times T. Why did we take Q? Because charge is given to us. Pay attention first, stop working. Everyone put your pens down. First try to understand what I'm saying. Since charge is given, we obviously have to look for a formula which is giving us about charge. Okay, so using this formula, I can find out I, which is equal to Q upon T. Okay, charge is given, time, make sure that you're converting it into seconds, right? And this I will be some fraction, won't even convert it into decimal, just keep it as something amperes. The step 2 is you have to find out about heat, right? For heat, we have 3 formulas. H is equal to I square RT. So R is not there, so obviously you cannot find out. Which formula of H has got I, we have got V, we have got T. Come on, tell me. H is equal to?
4,80,000.
First, which formula? I've given you 3 formulas. Yes, very good. So step 2 is H is equal to V times I T. I you have found out here, V you know, T we know, therefore we can cancel. Okay, it will automatically get cancelled out. Do that.
Ma'am, answer 4,80,000.
Yes. 4 lakh
80,000 joules.
Okay.
3.8 10 raised to 5 joules.
6 or 5. 1, 2, 4, 5. Are you sure you're not missed out on zeros?
96,000.
Make sure you're not missed out on zeros. When you put a point, that means it is 6. 4.8.
There are 4 zeros, there's 1 more, 5.
And
16.
T that gets cancelled out. So what you have done is only this one. No, 4 zeros, 1, 2, 3, 4. 1, 2, 4.
No, this is 6. This is 1, 2, 3 and 4. Where आया?
You got the 60, so I'll cancel it out. No. Wait. One minute. Can I ask you? You're doing the first part? Don't even do like this, keep it like that. Okay. Get it as a smaller version. Seconds. Just keep it like that. Also find out the first step. Capital I. Do I? Okay, have your see the mood at what happened? Go on. Okay? Finish? Where went? Everybody got your book? Max? How much is that?
And 2.67. 4.8
Yeah.
6
4.8
1.8.
times what?
into 10 raised to 5.
One more zero you're missing from somewhere. 96. What is so one? That is 30, no, so one more zero, so it is 4.8 into 10 raised to the power of 6. Did you get it? Okay.
Right, so next.
Got it or wrong?
6 including
The answer is 4.8 10 to the power 6.
Raised to power of 6. You have forgotten that this thing.
1 0.
1
10
0
raised to
6.
6.
Got it? Okay. Now the first one. Read the first question there.
The code of the metric not known by the heating element does.
So we are asking you to compare and contrast between two types of heating elements. Okay? Raj, what happened? Where are we? Still going on? How much? Girls, you finished? Okay, why don't you start writing the first one? Now, you are allowed to see the textbook, but answers should be individual. Come on, first writing. Why does the cord of an electric heater, try to understand. Suppose this is the electric, look at me. Suppose this is the electric heater. This is the cord. Did you understand? Will that become hot? No.
yes.
The cord does not become hot. Cord is this, the one that is supplying the current, okay? Does not become hot. While the heating element becomes, which is the heating element which is there inside the coil. So we have two types of wires. Do you understand? One is the coil inside the heater or the toaster or whatever it is, and the other one is the cord which is supplying. Now compare and contrast. Each one of you will write your own answer. Come on, quickly. You're allowed to look into your textbook, but no discussion. Think about the types of wires that we have discussed already. Got it? I gave you the name. You don't use the same wire here, but you use certain type of wires. Think about the electric bulb which I gave you. Come on, right? Fast, I'm giving you 5 minutes time. Don't waste my time. Okay, come here. First, you talk about the electric cord. What type of wire should be used there? Okay? And second, you talk about the heating element and what type of wire you should use there. Then you get your answer. Raj, I gave you something. The answer is open or no? Got it? I'll come and check. Gaurav, where are you getting stuck? Why you are taking such a long time? Come here. Come here. Come here. Yeah, I mistake. I told you don't even change this. Don't even put all these things. Just keep it as a fraction. Are you sure you put it as A to B or it is something else? Here only I think you have made mistake 96. Time is correct. So even if you keep it as 96,000, okay, divided by 60 divided times 60, just keep it like that. And when you substitute it here, okay, how much is V? 50. Okay. You substitute this value 96800 divided by 60 times 60. Time is क्या है? 60 times 60 to 60 ये पूरा कट जाएगा ना? That's all. So all that you have got is 96 times 5 and put all those zeros together. No discussion, right? In your own words. I don't want long answers, just 2-3 lines I want, that's all. Let me see how much of it you have actually absorbed. If you are paying attention in the class, we'll be able to see. Arav, this one. Ayush. Right first, then we'll discuss. No, which one? I want you to write it as two separate things. In a heating coil, okay.
I would
Of the cord. Or when we talk about the distance. No, that's not correct. It's not correct. That's why I'm asking you. I will explain. You are right. This part of it is correct. Now, why is the electric coil getting heated up? Think. Correct. Think in terms of R is equal to what? Directly proportional to L divided by A. Think in those terms. Then, take everything right about the electric coil. No need. Give it back. Anish, what did you write? Can you read out?
The element is made up of metal which has very high resistance.
Very good.
Therefore, the current passes through the wire becomes.
Very good. What else can you write? Talk about the thickness. Diameter of the wire is very thin and the length is also more. That's perfect. Okay, very good. Continue. Raj, what was your first point that is correct? Others listen to it.
The cord of an electric heater does not glow as it is a good conductor and allows the current to
Correct, it's a good conductor. The cord is a good conductor and therefore it is not getting heated up. Okay.
allows the current or heat to pass through it
Yes.
easily and avoiding overheating.
Correct, very good. Now write about the heating element.
Coil.
About the coil. Anish just said, no, he said the right points.
The coil is a alloy, right?
Yeah, it's in chromometer. Right, something. Finish. Yeah.
cord is further resistive or configuration of resistance only connected to current. The source energy continuously gets dissipated entirely.
What they are telling you as to why heat is being generated.
The cord.
No, God is not getting hot. Now you have to talk about the filament. Why is the filament getting hot? Vaishnavi, answer. Finished?
No, ma'am.
Okay.
Sir, I feel
No need. Hot no need. Only about the heating element you can tell.
more than
Filament you know. So really read what you have written.
I wrote about the does not go to the physical constructor
Mhm.
and the cord is made of alloy or a metal which has appropriate melting high
Melting point, okay. Okay, it gets heated up, it's enough, but then you talk about this, the filament is usually thin and long, such. So you can also write down the formula. R is directly proportional to L, inversely proportional to E, all that you can write.
Thin and
Long.
ma'am, it is a good conductor, that's why it allows the heat part to
Where the cord? Yes. It's the last, this you can cut it off.
charges that.
Make it short, there's no need for you to write a very long answer, as long as you got the words correct. No? Clear?
resistance is more, whereas the length of the cord is compared to the less.
No, there, we're not bothered about the length of the cord there. We just say that it is a good conductor, that's all. Here for resistance of the heat.
The cross-sectional area of the element is less as
Ah, therefore, ask higher. Is that okay? And maybe one more we can do if the third time for this. Yeah, maybe, yes. Children, did you do the graphical question? Ohm's law, I told you to do it in a graph.
Not
No.
in the graph, I saw.
I saw that in
Yeah.
You got it? Got it? Okay, so you get your graph next time. Tomorrow we have a class.
Yes. Yes.
Tomorrow we have a class.
First,
Let's say.
second,
Seven, let's
Third
say.
and fourth class.
Same class.
weeks.
No, it's,
Can we do question number 8? Boys, this is a simple one. Come on, do 50 question 8. Have you done? Question 8, have you done?
We have done 12 by 2.5.
We got it? Okay. Can we do the 9th one? Read the 9th one. A battery of 9 volt is connected in series with so many resistors, 0.2, 0.3, 0.4, 0.5 and 12.
Not the board will be common in all of this.
So only one part.
How much current will flow through the 12 ohm resistor? How many?
45 and first one.
First you write down the information, then it becomes easy for you to understand.
Solve the
Okay. What information is given and how are you going to approach it?
Now we have to only find for the 12 ohms ones.
What you should write?
How much current would flow through the 12 ohm resistor?
Okay.
So we have to find for only one ohm.
First you think, read the question carefully. Is it in series? Is it in parallel? What is happening? I'm asking you. Read it.
It is in series.
It's in series. In series, what is happening? If it is in series, what should you do? Yes. Okay. What happens to the current? Is it the same current or it's a different current passing in series? That will be the total resistance. V is given to us. You can find out I. And it is the same I which is passing through everything. That's a tricky question. Okay, whether it is 0.2 or 12, it is the same amount of current which is flowing. Chord is not chord is this is the chord.
We have to write about the wire.
The chord will not, it's a good conductor. There are coil inside.
So in this answer, just write.
So we have to talk about both the things. So we have to which allows
You have to write about the
like copper or amount of coil here. Greater than resistance. चलो must be hungry, no? Tired.
नीचे में
It's quite challenging.
रुको ये राहुल बॉटल क्या रे बहुत बोल रहा है बहुत थोड़ा भी अगर पड़ता ना इसके ऐसा विवाद होता है ना अभी बस
किसी और का बिस्किट वो खा रहा है
मालूम है यार किसका बिस्किट है वो
हेलो
हम नाम सॉरी भाई अरे भाई राजवर्धन को राहुल आएगा मारने को अरे ढक्कन सुन क्या बोलता है ये राहुल को ये बोला
अरे भैया
अरे जीजू जी राम राम
जीजू पायला को आपको बताया क्यों बोलते हैं हम नाम नहीं बताएंगे आप गूगल कर सकते हैं कारण नहीं बता सकते